Okay, so remember this is the very last thing that we ended with yesterday, and that's to graph a sinusoidal function with a period other than 2 pi. We're going to find the period, divide the period by 4, and add that value to the left endpoint of an angle with that length. So here it says sketch the graph of y equals 2 sine of 3x. So let's review a little bit. What's the amplitude in this graph going to be?
2.
The amplitude is 2. Good. The reason why it's 2 is because that's the number in front. Okay. What is B?
That would be B is 3.
B is 3. So to find the period, what I'm going to do is I'm going to take 2 pi divided by 3. So the new period of the graph is now 2/3 pi as opposed to 2 pi. So now what we're going to do is we're going to graph this. So I'm going to go up 2 because that's as high as it goes, and down 2 because that's as low as it goes. Now my instructions are going to be to graph 2 full periods. So what I'm going to do is start with one period right here, which is 2 pi over 3. Now if you remember, what did I do with that period? What was the second step on that previous slide?
A fourth of it?
Divide it into fourths.
Yeah.
Okay, the easiest way to do this, okay, is to first of all divide it into half. And so when I think of half of 2/3, half of 2/3 is? 1/3. So half of 2/3 here would be 1/3. And then what I'm going to do is take half of that. So what is half of 1/3? 1/6. The easiest way to do that in your head is to take the denominator times 2. And so then this number out here will be whatever pi thirds plus pi sixths is. It would be halfway in between 1/3 and 2/3.
Pi over 2.
I think this should be, oh yeah, pi over 2, what you said. Sorry. Okay, so now this is the one thing. If you wanted to check your work, this is what you could do. This is 1/6, right? That means this has to be 2/6, this has to be 3/6, and that has to be 4/6. Okay, so that's one period. Since I went ahead and told you that this is pi over 6, that means every tick mark is pi over 6. So what I'm going to go ahead and do is add another set of tick marks. And so this is where my second period is going to be into play. This will go all the way out to 4 pi over 3. Where did the 4 pi over 3 come from?
It's twice.
It's twice. Yep. Okay, so now let's review sine from yesterday. Where does sine start?
0.
0. Where will it go to next? Up. Where will it go to next?
Down. Down. 0. Up. Up. 0. Up. Down. Down. Up. Up.
Okay, so now we're going to go ahead and draw. Remember, this is a curve. It is not anything with straight lines. What values will this graph oscillate between?
2 and negative 2.
2 and negative 2. So what's the range going to be? The range in this graph will be? The range.
2 and negative 2.
Yep, negative 2 and 2. So the range would actually be written this way. So when our amplitude changes, our range changes a little. Okay, so the range here would be that.
You always start with the least number, or do you
Yep,
start?
always start with the lowest number. Let's go ahead and look at another one. Sketch the graph of y equals 3 sine x over 2.
Alright. So your range is.
And I'm actually going to change something here. I'm going to make this a negative 3.
Okay, that sounds awesome.
Okay. What's your amplitude going to be?
3, negative 3. Negative 3.
Amplitude's going to be 3. I'm going to put a little star here for me because that's going to tell me what the negative will do. Okay, that's just going to kind of be like one of those little reminders.
So why don't you put negative?
Because amplitude is always positive. Remember, amplitude was the absolute value.
Okay.
So now the period is going to be 2 pi divided by b. What is b in this problem?
It's 3.
b is 1/2. Okay, for those of you wondering where did that come into, another way to write x over 2 would be 1/2 x. That's the same thing. So b is actually 1/2. So if you take 2 pi and divide it by 1/2, what do you get?
Pi. 4 pi.
4 pi.
Oh, yeah.
Basically, if you think about it, it's taking 2 and figuring out how many halves are in 2, and there's 4 of them. So anyway, let's go draw our line. Whoop, there we go. How far up and down do I go?
3.
3.
Oh, this is easy peasy.
Superstar.
Okay, so I'm going to go over here to 4 pi.
Yupper.
Remember, I cut it into half, which is how many?
2 pi.
Cut that into half, which
1
is
pi.
1 pi.
And then 3 pi.
Then I'm going to go 5, 6, 7, there's 8 pi.
Yeah, those are easy.
So now I need to graph.
Alright.
Sine starts at
0.
0. My amplitude is 3, so that means I'm going to go up or down 3. I notice I have this here.
Go down.
I'm going to go down. That's what that's going to indicate, is that you're going to do the opposite. That's going to kind of be a mental note to yourself.
What's
The
star?
reason why you go
Basically,
down
where'd you get
is
the
because
physics?
it's a -3.
Uh-huh.
Okay, this negative sign, remember, that means that you're going to do the opposite. So we're going to go down first,
Why does it have a
then we're
star?
going to go up. I put the star there so that I would be reminded that there was a negative in the problem, because amplitude is not negative.
Could you put absolute, 2 absolute things and then put -3?
Amplitude is not negative.
You could put the -3 over by your problem.
Amplitude is positive.
But not
Can
amplitude.
you put -3 and 2 absolute signs? That makes it positive.
That's true.
I am looking for that the amplitude is 3. Okay, so when all is said and done, I better see somewhere that the amplitude is 3.
You better see a cute little star there too.
I don't care what you can put. You can put the star if you want. Okay, it's not that big of a deal.
Can I draw a barn?
Some of you are being difficult. All right, so now let's define frequency. Frequency is the number of cycles the function completes in a 1-unit interval. It's the number of cycles the function completes in a 1-unit interval. Now, a little bit about the frequency. The frequency is nothing more than the reciprocal of the period. It's the reciprocal of the period. And so basically, we could take 1 over the period and that'll give us the frequency, or we could take the absolute value of b and divide that by 2 pi. The number of cycles the function completes in a 1-unit interval, and then the frequency is 1 divided by the period. So now, if we look at this one, it says state the amplitude, the period, the frequency, and the phase shift. Okay.
Whoa.
And the phase shift. Then graph 2 periods of the function.
Maybe smart pick.
Probably. Okay, so first of all, I want you to go ahead and figure out what the amplitude and the period are going to be. Okay, so what do you think the amplitude is, folks?
1.
The amplitude is 1, very good. What do you think the period is? 2 pi over 3. Okay. So with that in mind, what's the frequency going to be?
3 pi over 2.
Frequency is gonna be what?
3 over 2 pi.
3 over 2 pi. So basically all you're doing is you're flipping those.
It's called flipping.
Okay. Now the phase shift. Where do you think the phase shift is coming into play? Or what do you think is telling us a phase shift?
Minus pi over 2.
This right here is telling us that we've got a phase shift. Now we need to think back to our section 1. Okay, when we had those shifts, remember we would shift left or right? Is this going to be a right shift or a left shift?
Right.
Right shift, good. It's going to be the opposite, so it's going to go right pi over 2. So now what we're going to do is we're going to go ahead and start.
So for phase shift, you just put arrow pi over 2.
That just means to me it's going to go right pi over 2. You could put right pi over 2 if you would want. This to me just indicates I'm going to move my graph.
That's what we need to put, is that.
Yeah, that's for the phase shift. Oh, I see, yep. I see what you're saying, yes. Okay, so my amplitude is only 1, so I go up 1, negative 1. I shift over to the right pi over 2. So basically pi over 2 here is my new starting point. So I'm going to put a dashed line to mean that I start there, just for my own bit of information.
How do you know it's to the right though? That's my own question.
Because it's the opposite of
Oh,
negative pi over
okay.
2.
And if it was a positive?
It would be to the left, yes. So then now the period is 2 pi over 3. So that means I start here and then I go over 2 pi over 3. Okay. So basically this isn't 2 pi over 3. This distance here is 2 pi over 3. So how do I find what that number is?
Pi over 2 plus 2 pi over 3.
Yep, pi over 2 plus 2 pi over 3. So basically, pi over 2 plus 2 pi over 3. What does that come out to be? So 1/2 plus 2/3. 1/2 plus 2/3, what do you get?
5/6. Oh wait.
1/2 plus 2/3.
Um,
1/2 plus 2/3.
7.
Thank you.
7.
7 pi over 6. Good, 1 and a 6th. So here you go. There are your 4 marks. So sine, in this case, has an amplitude of 1, a period of 2 pi over 3 has a shift of pi over 2. So now we're ready to start graphing. So where am I going to start?
Pi over 3.
Pi over 2, I'm going to start right here. Where do I go at my next tick mark?
Up to
Up to 1. Where do I go?
0.
0. Then I go negative 1. Then I go 0. Now if you notice it says to graph 2 full periods. How many periods have I graphed? 1. So I need to go to the right 4 more. And so I'm going to go up at my next one, down. So come test time, you're going to need to graph 2 full periods.
Doing a label the second period?
No, that'll be fine. Okay, questions? Kind of tying everything together. Right? So what we're going to do is we're going to look at another one of those. And then I think on the y's we might wait till those till tomorrow. The shifts up and down. So y equals 3 cosine of 2x minus pi over 3.
We do the same thing as last. Oh.
Amplitude,
3.
3. Period. 2 pi divided by what?
2.
So my
Pi.
period is pi. Okay. Frequency is what?
How did you know it was 2 pi divided
Frequency is 1 over pi. For those of you wondering what the frequency is, remember once you find the period, you just flip it for the frequency. And what's my shift going to be?
To the right.
To the right, pi over 3. Here is what your shift does. Alrighty, questions? Okay, so now we need to graph that. So first thing I'm going to do a shift of pi over 3. So I'm going to move over here, and I'm going to go ahead and, this is going to be my new point. Pi over 3. Now how far to the right am I going to go right here? What is this distance here got to be?
Pi.
That distance there has to be pi. So what number's here?
4 pi.
4 pi over 3, good. So, break, break, break. Okay, then we're going to go 1, 2, one more. High point, I'm going to go up 3 and down 3. So where do I start at the dashed line? I start up here. Why up here? Because it's a cosine. Where do I go next? Down, then -3, then. Okay, yep. And then up here. So, there's your cosine graph. Oops, I missed that point a little bit. There we go. Okay. So that's the phase shifts. So this is what we're going to do. We're going to call it good with the phase shifts now. Tomorrow what we're going to do is we're going to talk about the vertical shifts. So this is where we're going. And then tomorrow we are going to do a double shift. So tomorrow we're going to do an up and down shift, and then we're going to do both up and down and left to right. So this is what you need to do. So on page 264, you should be able to do through 15. You should be able to do through 15.
Why not 17 and 19?
16 and 17 are both vertical shifts, and then 18 and 19 are both. And then 31 through 34 are looking at a graph and telling me what the graph is of. So.
Things we have to do.
Yep. So keep working. Tomorrow we'll probably finish the section. So we're going to be looking at the section being due Thursday, maybe Friday-ish at the latest.